And so some of this is probably going to be a review from math. And now that's good too. Okay, in science, we always have to have a number and a unit. Okay, otherwise our number doesn't say anything. So if we're looking at the proper aspirin dose and it says 325, we have no idea what 325 means. Is it milligrams? Is it a volume? Is this a length? So we need to specify a unit. Okay, that's, you guys can obviously see that's obviously important. A fast time for the 100-meter dash, if it's 10, I don't know what that means. Did they take 10 minutes to run the 100-meter dash? Is it days? Okay, so our number always has to have a unit. And this is really important for the lab. I'm going to look for that. If it's in a table and it says like meters at the top, you wouldn't need to put meters on each of the numbers. But if you're just reporting a number, the number should have a unit. Okay. We use the SI system in science, which is we just agree upon the unit, and the whole world uses the same units. Okay. So what would we use for length? What is the SI unit for length? Yep, good, meters. Okay, and what's our symbol? Good. Okay, what would we weigh? If we're trying to find the mass of something, what would we use? Good, grams. Very good. And our symbol is G. How about volume? Okay, centimeters cubed is 1. The metric base unit for volume is going to be liters. Okay. Liters. Let's use or big L. And we can write that one down too. We can also use centimeters. Good. What do we measure time in? Okay, yeah. The time is just standard, so minutes. I don't know how to spell minute. Minute. Okay, or second. So minutes, seconds. Okay. All right, those are the units that we're going to use in here. All right, so then we can take a base unit and we can convert it into a different unit. Okay, so these work really well with the metric system. Okay, so we can take a centimeter and we can convert it to a meter by multiplying by 100. Okay. This kind of table is in ALEKS, so you were going to have to do this on the assignment and on the test. So let me show you where it is in ALEKS. Where did my ALEKS label? Is it? Very good. So if I'm in ALEKS and I just start working on an assignment, or if I'm on a test, the screen's going to look the same. Over here on the test, you get to use the calculator. So I would figure out as we go, start using the ALEKS calculator. You also get data on the test, and you get the periodic table. You don't get the ebook on the test, but there's a place where you can look at the ebook on the assignment. I don't know. Okay, so if I go to data, you get this on the test. It takes a minute to load, and then there's different topics here. This SI prefixes is a table of different conversions. Okay, so how many is a deca? Well, that's 10 to the 1. Okay, that's 10. Hecto is 10 to the 2. So This is something you don't have to put on your note card because it's in Alex. This will also be there on the test for you. Okay. Okay, let's go back to our slide. Questions on that? Yeah.
The periodic table on the test, do you use that one? Or
Yes. Yep. This is the periodic table. I mean, you can use that one, the one on the wall. But yeah, this is the one that you will be able to use on the test. And if you click on an element, it brings up some things.
Test analysis.
Test is analysis. Yeah, final is analysis. Homework's analysis. So it'll be important to get two elements. Where are we? Okay. All right, so let's try a few of these. How many centimeters are in a meter? Do you know? 100, yeah. Oh, I need to turn my pen back on. 100 centimeters is 1 meter. Okay, how many milliliters in a liter? Good. Yeah, you got this. 1,000 milliliters for 1 liter. Good. How many liters in 1 milliliter? So it's just the opposite, right? Yep. So we could divide this by 1,000. Oh, yeah. Oh, I've confused myself. How many milliliters? So for 1 milliliter, that's 1, 2. Is it 0.1, 2? Okay, there we go. 1, 2, 3. 1 liter. 0.001 liter. Okay, so I just divided by 1,000. Oh, I moved it from the wrong spot. There we go. 1, 2, 3. And eraser. Okay, decimal goes here. All right, how many centimeters are in a kilometer? How do we do that one? Okay, how do we get there? You're saying 10,000. Okay, so 1 kilometer. So you're saying multiply by 1,000. So there is, for every 1,000 meters, there's 1 kilometer. Do you agree with that? So then kilometers on the bottom, kilometers on the top. Now we're in meters. And one more thing, what do we need to do? We need to go from meters to centimeters. So if we multiply by, we know there's 100 centimeters for 1 meter. So 1 meter is 100 centimeters. Then we'll get 10,000 centimeters. Okay. Questions on that one? We're doing okay? Okay. Okay. So I like to use the Alex chart in the data. That helps me get these right every time. And I don't have to write it down on a note card. Okay, we also have, we can convert English to metric. We're not going to worry about this too much because Alex just has us working metric. Okay, so, all right, the next thing that we're going to talk about relates to our first lab. So, in science, we can have exact or inexact numbers. So 10 fingers, 10 toes, 1 meter is 100 centimeters. Are these exact or inexact? They're exact? What do you think?
Yes.
Exact? Okay. What about these ones? If I'm measuring something, this is 15.3 centimeters, 100.8 grams, 0.0034 milliliters. Are these exact or inexact? So they're measurements. So anytime we're measuring, it's going to be inexact, okay? So these are measurements. Okay. Anytime we measure something, it's inexact. Anytime we count something, or anytime we have a unit conversion. Something. This is a definition. Then this is going to be an exact number. Okay. I can't mess. Well, I could mess up, but if I count 10, then I have 10 meters. If I define 1 meter to be 100 centimeters, that's exact. That's a definition. Okay, questions on this? So this is what our first lab deals with. Okay, we talked about this. Exact counts is from counting or a definition, and inexact is from measurement or observation. So we're going to look at this. When we measure something, there's always a little bit of uncertainty. Maybe I measured it slightly different than you. Okay, we got it. All right, so this is where I'm going to hand you this. This is for your next, for the lab, okay? So this is the only page that we can copy out of the lab book, okay? Because you're going to cut this page up. Okay, this is yours to keep. We're going to just talk about the rulers on here for a minute. When we measure with a ruler, we get one place value of uncertainty. So we can go 1 decimal beyond the ruler. So up here, when we're measuring this fish, if we have increments of 10 centimeters, and we're at 50, we're between 50 and 60, our uncertainty is somewhere between 50 and 60. Okay, so we would get to estimate 1 more digit beyond what our ruler has. Okay, so our ruler is in tens. We get to estimate 1 beyond that. We get to estimate the ones. Does that make sense? Okay, down here, this ruler has millimeters. So we can see the fish is at least 53, and then we get to estimate 1 beyond that. So all of our measurements with a ruler, we get 1 beyond the whatever is our smallest hash mark. Okay, so you guys talk to your neighbors. How many decimal places do you get with ruler A? How many decimal places do you get with ruler B? And this is what you're graded on lab 1. So think about it, and then we'll talk about it. I know our class is kind of small, but you can talk to your neighbors. Okay, what do we think on ruler A? Ruler A. How many decimal points do I get on ruler 1?
No. Yeah.
So we always get 1 beyond our ruler. So we have the ones place, right? So ruler, let's pull it up on here. Then I'll have to draw. It's under here somewhere. Okay, so we've got down here on ruler 1, or A, ruler A, if we measure something in between 1 and 2, we could say this will give us 1 decimal place. Ruler A gives us 1 decimal. So we could measure something that's like 1.3, or maybe if it's between here, maybe it's 4.5, okay? We get 1 decimal place with ruler A. Does that make sense? Okay, how about ruler B then? Yes, we would get 2. This ruler B gives us 2 decimal places. Because it could be between these 2 lines, okay? And if it's right on the line, what should we do? What if it's like obviously right on 11? What would this one be? 11. And we would have to include, we know it's right on the right on that line, so we do 11.0, okay? What if it's right, obviously right on this line? Good, we would do 11, so 10.5, and we get 2 decimal places, so it would be 10.50, right on that middle line, okay? So always, for this lab, I need to see if you're measuring it with ruler B, it needs to have 2 decimal places. If you're measuring it with ruler A, it needs to have 1 decimal place, okay, even if it's a 0. That's what I have to grade you on for this lab, okay? All right, questions on that? And we have a whole day scheduled for this lab. It just fits in our lesson today. So you can do this at home if you want, but we will also take time in class to do this lab. But hang on to that paper, bring that paper when we do the lab in class. Okay, back to our notes. Okay, now we're talking about sig figs. So we're going to just briefly go over this, and then I will give you a paper to work on. So significant figures are the digits in a measured number, including 1 estimated digit, okay? So ruler A could have 2 or 3 significant figures. Ruler B could have 3 or 4 significant digits, okay? The biggest rule probably is that all non-zero digits are always significant, okay? So if we're looking at this number, they are all non-zero. These are all significant figures. So this number has 3 significant figures. These are all significant. So they must have had a really precise scale. It goes out to 3 decimal places. This has 6 significant figures. Okay, let me hand you out this worksheet. So what I want you to do is I want you to go through and look at these rules. I've put the rules and an example. And I want you to figure out, if you can figure out which of the bottom ones are, like how many sig figs does each of these have, okay? Work with your group. We will talk about rounding after we do this. So first do this top part. If you want to jump to the rounding, if you're done, that's okay. So do sig figs first. Look at the pattern. Look at the rules. And then see if you can figure out the bottom few rows. I'll give you 2 minutes to try to work through that, and then we will look at them together. good. I see some people working on the filling in those boxes at the bottom. And we'll go over it too, so let's see if you can see the buttons. This is our schedule. Have you got this yet? Okay, and then these are the syllabuses. So there's two classes. One's the lab and one's the class. You'll get a separate grade for the lab and the class. Okay. And then the CRM numbers are on the bottom of this. I can also repeat. Okay. Yep. Okay, let's go over it together. What do we think about this one? This matches your worksheet, right? Yeah. What about this one? How many sig figs does this have?
2.
2, good. So what I like to do is I draw a line. Oops, I forgot my pen. I have to turn my pen back on. And then I have to go back. Okay, so if it's a 0 before a number, it doesn't count, okay? So I draw my arrow over until I hit a number, and then everything after that number, if I have a decimal, is going to be significant. So this is 2 significant figures, so 2. Okay. This is kind of confusing. There's like a lot of rules, a lot of things to keep track of. There are some ALEKS topics with this, so I practice those. Make sure you're familiar with those. Moving forward, all of the ALEKS homework, all of the labs will require you to understand the sig figs. Okay, so make sure that you're understanding this. Okay, how many here? 3. Good, 3. I'll just write 3. 3 sig figs. Okay, that looks like a 31. All right, how about this one? Good. The 0 inside the numbers is also significant. So this is 4. Okay, how about this one? So this one is tricky. Why is this one? This is 1. Why is that? Because it doesn't have a decimal. If there's no decimal, then that 0 at the end doesn't count as significant. Okay, this would be like measuring with the ruler that is in increments of 10. We can't put something there. Okay, so this would be 1. Good. How about this one? 3. Good, 3. Good. How about this one? Good. We ignore these zeros until the 6. Then all of these are significant. Even the 0 at the end because it's after a decimal. Okay. How about this one down here? 2. Good. We go through the 0. This is 2. How about this one? This is just 1. Good. Because we hit that 1, but then there's no decimal, okay? So only the 1 counts as significant. Okay, you guys feel okay about that? Okay, this is kind of weird. You are going to have to remember this going forward, so make sure that you're comfortable. Make sure you remember on labs and on the ALEKS questions that you need to do sig figs. You need to remember that. You guys are okay there, too? Okay, good. Oops. Okay. And I think you've got the rules. Okay, so we're going to jump to the math. So we have to, when we're doing math, if we're adding or subtracting or multiplying and dividing, we have different rules for keeping the right number of significant figures. So these are our rules. If we're multiplying or dividing, we keep the least number of sig figs. Okay, so if we're looking at this, we have 351.2 miles per 5.5 hours. How many sig figs does this have? 2. How many sig figs does this have?
4.
Yeah, good. 4. So we look at which one has the least sig figs. It has 2. So when we go to round this, we can only keep 2 sig figs. Okay? Because this is the least number of sig figs, so we can only keep 2 sig figs. Now we need to round. Okay, so what is this going to round to? 64. Good. Okay. Okay. The other thing that Alex really wants you to do is put a decimal here. If you have a number and you know it needs 2 sig figs, you should put a decimal here. And then everyone's happy because we know that, well, okay, there we go. This has 2 sig figs, there's not a 0 at the end. Everyone's clear. Okay. I'm pretty sure that's the end of lunch. We aren't supposed to leave until the 45. Okay. So we've got 40 minutes.
Students and teachers, we just want everyone to be clear that that bell is for first lunch students to head to third period. So first lunch is now over, head to third period. Thank you.
Okay. Okay. Okay, now go ahead and try the rounding. So, have you guys done rounding in math before? Okay. Hopefully, and if you haven't, we're learning it again. So between 0 and 4, you just cut off the number and you stop at the number of sig figs. If the number next to where you're trying to cut off is so like this one is, if we're cutting off here, this number is bigger than 5 and 9, or excuse me, between 5 and 9, then we're going to round this number up. Okay. So just same rounding rules. Go ahead and practice. Oh. Yeah, go ahead and practice on your paper. The next section is rounding. Okay, then I think this is, what is this? So this is, oh, that's what we have. Oh, I mean, the numbers were way over. Okay. Oh, so I also got confused. These ones are already done for you. This is like the example, and then you can do this last one. Yeah. They were so far over, I got confused too. Maybe I should have sent you that. Okay, let's go over these ones. So if we have this long number, maybe it came off our calculator, but we know it can only have 2 significant figures. What should we do with this number? Sorry? Okay, we're gonna drop 7. So we can only have 2 sig figs, and so then we're gonna round up. So this will be 110. Okay, with no decimal. This gives us 2 significant figures. Okay, remember that 0 at the end with no decimal is not significant. All right, how about if we're rounding to 3 places? What will we round to? Good. So it'll just be 107. So that's 3 significant figures, and we can put a decimal. We can put a decimal after that. How about this one? Good, 107.2. How about this next one? If we need 5 significant figures. We're just going to keep going, right? 107.2, and then, good, round up to 4. 6 places, so we have the same thing, 107.237. Okay, good. And that's our 6 significant figures. Okay, we're doing okay? All right, questions on this? Okay, and this will, it's not going to look like this, but Alex will have you practice this too in your chapter 1 assignment. Okay. Okay, what I want to do here is let's just talk about how many significant figures we'll end up with. Because I know you can type stuff into a calculator. But if we have 50 times 35.5, how many sig figs can we end up with? This is multiplication. So this one has 3 sig figs, right? How many does this have?
2. What?
This one has just 1 because there's no decimal. So only the 5 is significant. So this is just 1. We always go with the least number of significant figures. So when we have our answer, the answer can only have 1 significant figure because we're multiplying and dividing. Okay. The next one. How many sig figs is this? 3. This is 3 significant figures. How many is this?
2.
This is just 2. Remember, if it's a leading 0, it doesn't count. This is very confusing. So lots of rules. Just keep with us. Keep practicing. Okay, this is 2. So how many can our answer have if we are dividing?
2.
Good. We can have the least amount. This is the least amount. Last one. How many gallons per hour? I don't know, it says miles here. Okay. So how many sig figs here?
2.
How many here? This is just 1. Good, because there's no decimal. So just the 3 counts. So how many sig figs can we have? That's a 1. That looks like a 2, but it's a 1. So at the end, we can only have 1 sig fig. Okay, let me write this down. I need to fix this. This should be gallons per hour. Okay. All right, we have different rules if we're adding or subtracting. Okay, so that sometimes gets people confused. When we're multiplying or dividing, it goes by least sig figs. When we're adding or subtracting, it goes by least decimal places. Okay. So, how many decimal places does this have? You're just looking here. This has 2. This has 1. So our answer can have 1 decimal place. Even if it turns out to be a 0, we can only have 1 decimal place. So I'm going to do this on my calculator. You can do it in your head, then that's awesome. So 10.11 minus 3.6. And this answer that's from my calculator says 6.51, but I can only have 1 decimal place at the end because this one has 1 decimal place. So my answer, I'm going to round to 1 decimal place. So 6.5 is going to be my answer there. Okay, so we've got rules for multiplication. This is our rules for adding and subtracting. Fewest decimal places. If for some reason this turned out to be a 0, we would still want to keep that decimal place. Okay, don't lose significant digits. Like it wouldn't be just 6; it would be 6.0 without a 0. Okay. So let's just do our decimals. If we have a 12-foot board and it's shortened by 6.75 feet, how many sig figs can we report? Or, yeah. Is this gonna work? Yeah. How many decimal places can we report? Just 1 decimal place. Least amount of decimal places, this is 1. So we can only have 1 decimal place, whatever our number is. Okay, how about this one? We can also only have one. Okay, good. How about the last one? Good. This one has 1 decimal place. This has 2. We go with the least amount of decimal places. Okay. All right. Okay, the last thing that we need to talk about today is scientific notation. So we've got our coefficient times 10 to the exponent. So this coefficient needs to be between 1 and 10. Okay. Let's see. Oh, and when we're talking about significant figures with scientific notation, this is the only number that counts for significant figures. This is where we're going to count our significant figures, and that coefficient. Okay, that will come up. That will come up. Okay. And then the exponent just needs to be an integer. So just like a whole number, like a no decimal number, integer. Okay. How do you guys feel about scientific notation? Should we walk through it? Okay. Okay, so if we have this number, 2,500, how many sig figs does this have? 2. So when we represent this in scientific notation, we also need to show that it has 2 significant figures. So our decimal, it's not shown, but our decimal is here. Oops, is my pen going to turn off? And then I'm going to move my decimal so that the number is between 1 and 10. So here we go. 1, 2, 3. Okay. So I moved my decimal. Now I have 2.5, and I moved it 3 to the left. So this is going to be 2.5 times 10 to the 3. And then I use this part of my scientific notation to see how many sig figs I have. So how many sig figs does this number have? Still has 2. Had 2 sig figs here. I still have 2 sig figs here. Same number. Does that make sense? We're doing okay? Okay. All right, perfect. If we move the other direction, then it's going to be a negative number. I don't know, there's 2 of those. Okay, and then going backwards, this just tells us how many decimals to move and which direction. So if it's a positive number, we're gonna go to the right. If it's a negative number, we'll move to the left. So if it's a positive number, this number needs to get bigger. If this exponent is negative, then our number needs to get smaller. So 2 to the right, 1, 2. This would be 280, and we would have to show that decimal place. So looking back up here, how many sig figs does this have? This has 3 because we have that decimal, and so that makes the trailing 0 significant. And so then this is a decimal. When we come down here, now it's in standard notation, we also have 3 sig figs. So both standard notation and scientific notation should both show the same significant figures. Okay, I think you guys have some practice ones. Great. Yeah, go ahead and, if you haven't already, do those last 2 rows. Practice doing conversions between scientific notation and standard notation.
So the exponent has how many decimal places you move?
Yep, and then you either move it to the right or to the left. Yep, that's right. Okay. All right. I realized I didn't put these in my slides. How did that go? Did that go okay? Is there any that you want to go over up here? I just realized I didn't put them on my slides. Very good. Okay. All right, the last thing. What if we have something like this? Where we have, how many sig figs is this? 2, good. And this is 2, so we have 2. We have 2. We know 10 times 10 is 1,000. How do we get 2 sig figs out of that? What can we do? Good. Yes, so we're going to take this number, we're going to convert it into scientific notation, and then we can easily show how many sig figs. So our decimal is here, right? So 1, 2, 3. What's this going to end up being? Blah, blah. So 1 point. If I have this, now we have 2 sig figs. 1.0 times 10 to the 1, 2, 3, 3. So this is 1,000, but it's now I can clearly see this is 2 sig figs. That's kind of ambiguous. Okay. So that might happen in ALEC. So if it's being weird, you might have to write it in scientific notation to show the sig figs. Okay, I think that's our last thing. Oh, I put that at the wrong spot. That's fine. Okay, we have, depending on if they change the bell schedule, we have like 20 minutes before the end of class. So feel free to, I would probably work on the ALEX. You could also pull out the lab book and work on the pre-lab. I think we know enough now, we could work on that pre-lab. And you can always borrow books in the classroom too. You don't have to bring your lab book back to work. Any questions before we kind of end today? We're good? Okay, all right, I can wander around and help if you need questions. Yes.
So we need that pre-lab done.
No, we're not doing the lab till next week. Let me look. When is our, maybe it's Friday. That is a good point.